Kelvin, above absolute zero, and it's very difficult to keep a surface hotter than that. In fact,
in the early hours of July 2025, inside a quiet control room thousands of miles away from public attention, something unusual appeared on a computer screen. At first, it did not look dramatic. No explosion. No flashing alert. Just a moving point of light, captured by an automated telescope scanning the sky as it did every clear night. But within hours, astronomers realized this object did not behave like anything they normally tracked. It was not an asteroid bound to the sun. It was not a familiar comet returning on a predictable path. And it was not something that belonged here. This object was passing through our solar system, but it did not originate from it. What scientists were observing was later named Comet 3I/Atlas, only the third known object ever confirmed to have arrived from outside our solar system. To understand why this discovery mattered so much, we need to go back to the moment it was first seen. The detection came from the Atlas survey, the Asteroid Terrestrial Impact Last Alert System. Its job is simple but relentless. Scan the skies every night, looking for moving objects that could threaten Earth or reveal something new. On July 1, 2025, one of Atlas's telescopes in Chile detected a faint, fast-moving object. At first glance, it looked like many others that pass through the inner solar system every year. But when astronomers began calculating its trajectory, the numbers refused to make sense. The object's orbit was not an ellipse. It was not circular. It was not even loosely bound to the sun. Instead, its path formed a hyperbola. That single detail changed everything. In astronomy, a hyperbolic orbit means one thing: the object is not gravitationally tied to the sun. It is moving too fast. Its trajectory is open-ended. It will pass through once, and never return. This meant only one possible conclusion. The object came from interstellar space. As scientists traced its orbit backward in time, the evidence became undeniable. Long before it entered our solar system, long before it felt the pull of the sun, Comet 3I/Atlas was traveling between the stars, drifting through the vast, cold space separating stellar systems. This realization placed it in an incredibly rare category. Before 2017, humanity had never confirmed the existence of any interstellar visitors. Then came Oumuamua, a mysterious object with no visible tail. 2 years later, Comet Borisov followed, clearly active and comet-like. Now, in 2025, 3I/Atlas joined this exclusive group. But unlike Oumuamua, which was already leaving when discovered, and unlike Borisov, which appeared faint and distant, 3I/Atlas arrived with something astronomers could study in detail. It was active. Images soon revealed a faint cloud of dust surrounding its nucleus, evidence that sunlight was heating its icy surface, releasing gas and debris. This confirmed its classification as a true comet. Yet it was no ordinary comet. Its speed was extreme. Its origin was foreign. Its journey likely began millions, perhaps billions, of years ago, around a star system we may never identify. As news spread through the astronomical community, telescopes across the world turned toward the object. Data archives were searched. Older observations were recovered. Scientists discovered that Atlas and other facilities had unknowingly recorded the comet weeks before its official discovery. Those pre-discovery images allowed astronomers to refine its orbit with greater precision, and the conclusion remained unchanged. Comet 3I/Atlas did not belong to our solar system. It was merely passing through. Despite the excitement, one question immediately concerned the public. Was it dangerous? The answer, thankfully, was clear. Comet 3I/Atlas poses no threat to Earth. At its closest approach, it will remain about 1.8 astronomical units away, roughly 270 million kilometers. That distance is safely beyond Earth's orbit. In fact, even at its closest approach to the Sun, expected in late October 2025, the comet will only venture slightly inside the orbit of Mars. There would be no collision, no disturbance, no hidden danger. What remained, however, was scientific opportunity. For the first time in history, astronomers could observe an interstellar comet in detail while it was still approaching the Sun. A visitor from another star system was revealing itself, quietly, steadily, to anyone prepared to look. And humanity was ready. As Comet 3 I/Atlas moved deeper into the inner solar system, the world's most powerful instruments began to focus their attention on it. Among them was the Hubble Space Telescope. On July 21, 2025, Hubble captured one of the most important images ever taken of an interstellar object. The comet appeared surrounded by a faint, teardrop-shaped cloud of dust, a visible sign of activity driven by solar heating. This dust cocoon told scientists something crucial. The comet was made of volatile material, ice, dust, and frozen gases, similar in composition to comets formed in our own solar system. Yet its isotopic ratios, activity levels, and surface behavior could carry subtle clues about the environment in which it formed. Hubble's observations also allowed astronomers to estimate the size of the comet's nucleus. Early measurements suggested an upper limit of about 5.6 kilometers in diameter, though it could be significantly smaller. This range alone made it scientifically valuable. Unlike Oumuamua, whose size and shape remain uncertain, 3 I/Atlas presented a clearer target, one that could be studied using multiple wavelengths. Soon, other missions joined the effort. The James Webb Space Telescope began infrared observations, searching for chemical signatures in the comet's gases. Instruments like TESS, SWIFT, and SphereX contributed additional data, while spacecraft orbiting Mars observed the comet from a different vantage point. Even probes designed for entirely different missions, studying the Sun, asteroids, or distant planets, were able to collect supplementary observations. This unprecedented coordination turned 3 I/Atlas into one of the most closely monitored interstellar objects in history. But what were scientists hoping to learn? The answer lies in what comets represent. Comets are time capsules. They preserve material from the early stages of planetary formation. In our solar system, they reveal what conditions were like more than 4 billion years ago. An interstellar comet does the same, but for another star system. Every molecule released from 3 I/Atlas carries information about temperatures, radiation levels, and chemical processes that occurred far beyond our Sun's influence. If differences were found, even small ones, they could reshape our understanding of how planetary systems form throughout the galaxy. As weeks passed, the comet continued to brighten slowly. Ground-based telescopes tracked its motion until September 2025, when it moved too close to the Sun's glare to observe safely. For a time, it disappeared from view. But its journey was not over. By early December 2025, Comet 3 I/Atlas would re-emerge on the opposite side of the Sun, allowing astronomers to observe it again as it departed the solar system, never to return. This brief window, measured in months, represented the only chance humanity would ever have to study this object. Once it leaves, it will drift back into interstellar darkness, continuing a journey that began long before Earth existed. Comet 3 I/Atlas will not change the course of human history in a dramatic way. It will not strike Earth. It will not alter our orbit. It will not bring messages from distant civilizations. And yet, its importance is profound. For centuries, humans believed the solar system was an isolated island, unique and self-contained. That belief has slowly eroded as we discovered exoplanets orbiting distant stars. Interstellar objects take that realization one step further. They are physical proof that material moves between star systems, that planets eject debris, that comets wander freely. that what forms around one star can travel across the galaxy. 3I/Atlas reminds us that the boundaries of our solar system are not walls. They are thresholds. Every interstellar object that passes through offers a glimpse into environments we cannot visit. It allows us to test whether the chemistry that formed our world is common or rare. And perhaps most importantly, it humbles us. This comet did not come for us. It did not arrive with purpose. It simply crossed our path. For a brief moment in cosmic time, humanity was able to observe it, to measure it, to learn from it. Then it will be gone. Long after our telescopes fall silent, Comet 3I/Atlas will continue its silent journey through the galaxy, carrying with it the story of another star system, written in ice and dust. A story we were fortunate enough to read, just once,